Hi everybody, hope everybody's doing well. Just want to, I don't think I'll be able to live teach because I'm home with my kids, so I'm making this video to knock things out and hopefully make our lives a little bit easier as we continue on with our class. Alright, so the other day we looked at circumference, partial circumference. They were looking at partial area. So area of a sector. Area of a sector is a part of a sector. Restart. We're talking about the area of a sector. The definition of a sector is a part of a circle enclosed by two radii and the intercepted arc. So today we're going to be finding areas of, think about like pizza slices, right? They're all like pizza slices cut out of the pie. And again, we go back to geometry in this situation. In geometry, we had a formula for this. So the other day with the sector length, it was S equals theta r. That was our new formula. And our old formula is the n over 360 pi diameter. So we still have that setup from previous year. Area equals n over 360 pi r squared. So that formula is still good to go. On the next page, we'll talk about the new updated formula. So here's our situation. TOR, 60 degrees. Radius is 6. So our area equals 60 over 360 pi times 6 squared. 60 over 360 pi times 36. Do some canceling. 60 over 10, 6 pi, in this case, units squared. Alright, so the cleanest, best answer, if you leave it in terms of pi. I know a lot of people look at that and they hate that because it just doesn't seem like they're done. Do less work. Don't do 6 times pi. That is our best final answer. Alright, a sector has an arc length of 16 centimeters and a central angle measuring 150. Find the area of the sector. Alright, so we're combining here. We're using both these formulas along with our new formula. Alright, so a sector has an arc length of 16 and a central angle of 150. Alright, so I see the central angle in degree mode. I'm going degrees. 16 equals 150 over 360 pi diameter. Alright, so do some simplifying here. 15 divided by 36. So I got 16 equals 5/12 pi diameter. If I do 16 divided by 5/12, then divide by pi, I got a diameter of 12.22, in this case, centimeters. Right, now we want the area. Well, the first key thing is that if that's our diameter, our radius in this case would be 6.11 centimeters. Right, so now area equals 150 over 360 pi times 6.11 squared. Area equals 48.89 centimeters squared. And just like, thinking back to our previous unit, right? If, with sequence and series, if you couldn't solve it with one formula, well, then you got to use the other. And that's going to be consistent here too. If you can't find the area given the information you have right away, you probably have to use the length formula to get information to then find the area. Alright, so now, our other formula. Right, so if I took my formula, I modified it. So instead of having 360, I have 2 pi. Instead of n, we go with theta. So if I do a little simplifying here, I cancel out my pi's. So that gives me, in this situation, theta over 2 times r squared. If I separate that, divide by 2, well, divide by 2 is multiplied by a half. 1/2 theta r squared. That's our formula for talking about radians. And again, just like the other day, it comes from the n/360 formula. We just slightly modify it to better work in the situation. Right, so area equals 1/2 theta r squared. All right, here we go. A sector has an arc length of 16 centimeters and a central angle measuring 0.95 radians. Radians, right? That's telling me I'm using the 1/2 theta r squared formula. Find the radius of the circle and the area of the sector. Right, so, do we have enough information? No, we don't have our radius. So 16 equals, well now, I got my options. S equals n/360 pi diameter. S equals theta r. Well, since we're in radians here, I might as well go with the radians formula. Alright, so S16 equals theta r. Alright, so 16 equals 0.95 r. Divide by 0.95 r. R equals 16.84 centimeters. Now I'm good to use my area formula. 1/2 theta, which is 0.95, times 16.84 squared. Area equals 134.7 centimeters squared. Now if you wanted to, right, there's nothing wrong with the math I just did. If you like, some people sitting there and like, no, I feel so much better with this formula. That works, you can do it. So here, we would have to change 0.95 times, so if we want to change from radians to degrees, 180 over pi, which would equal 54.4 degrees. So if you did this entire problem with 54.4 degrees, you will get the exact same answer. Does not matter which way we do it, it will work out. Promise. Alright, a sector has arc length of 12 and a central angle measuring 1.25. Find the radius of the circle and the area of the sector. Same idea. Right, but know what? I'm going to do this one in our other setup. I'm going to change it to degrees. 1.25 times 180 over pi. So I got 71.62 degrees. Alright, so then if I go my other formula, 12 equals 71.62 over 360 pi diameter. Alright, so 12 times 360 divided by 71.62 divided by pi gives me my diameter of 19.2 centimeters. I divide that in half, and my radius is 9.6 centimeters. Alright, so if I'm sticking with the n/360 formula, area equals 71.62 over 360 pi times 9.6 squared. Area equals 57.6 centimeters squared. And again, I chose to go with the degree formula. If you went with the radian formula, this would work out fine. Alright, last example. And look, I'm telling you, when we have our exam, right? When we have our exam, what day is our exam? We're looking, is it this week? I think it's next. Our exam on Monday. This problem is 100% going to be on there. And I tell you that because every year I give this problem, and every year people really struggle with it. Okay, so, right, so I'm going to draw my picture. It's going to help me out. A circle radius 9 inches has a central angle 11 pi over 6. So 11 pi over 6. If I convert that, 11 times 180 divided by 6, that is 330 degrees, which puts me in the fourth quadrant. Determine the area, and we have a circle. Whoop, need that too. A circle of radius 9. So from here to here, that is 9. Has a central angle of 330. Determine the area of the sector of the reference angle. The reference angle. That's the key word here. What's the reference angle? If we're in quadrant 4, 360 minus 330, our reference angle equals 30 degrees. 30 degrees. That's what we're looking at. We are finding the area of this with the reference angle of 30. That's where people make the biggest mistake. We have all the information we need. People use the wrong angle. So now, the area equals 30 over 360 pi times 9 squared. The area equals 21.21 inches squared. And if you wanted to, I keep throwing this out there, right? So the reference angle in here, if we were talking about radians, would be pi over 6. So area would equal 1/2 pi over 6 times 9 squared. And now give us the exact same area as this. Alright, people. Short lesson, not a bad thing, but I guess I wanted to make sure that you would get this information if I wasn't able to deliver it to you. Alright, so we'll join back up on Zoom. If you have questions, fire away, and we'll make sure everything is going okay.